Good morning, everyone. Welcome to Test Prep Time Live. My name is Oliver Luisi. I'm the Director of Tutoring here at Method Test Prep. I am going to be talking a little bit about system of equations today, a pretty common topic on the math, on the SAT and the ACT, but really fundamental and important topic in general for algebra. Just a reminder, we'll be doing these Facebook Live sessions every day at 11 a.m., Monday through Fridays. So join us again tomorrow and next week. Feel free to chat in any questions. I'll see if I can grab some answers for you. And I'll stay on for a minute or two at the end for any final questions. All right, let's jump in and take a look. Just a reminder and a refresher on the basics of linear equations, which is a fundamental aspect to know before getting into a system of equations. And we did talk about linear equations in some previous sessions. So this is really just a quick review. Hopefully many of you are familiar with linear equations. Just wanted to look at a couple of the key pieces that we need to understand and know in order to do system of equations problems. The first thing to note is that linear equations most often will appear in the form of the slope-intercept form, which you see here at the top, y equals mx plus b. The two important and critical pieces of the formula are the m, which represents the slope, and the b, which is the y-intercept. Now, what is slope but simply the gradient of the line, meaning how much is it going up and over as you move along the line? So if you were to measure exactly your movement vertical and your movement horizontal, it would stay consistent, and that's what makes a line. It has a consistent slope or consistent or constant rate of change. The intercept b is the place where the line crosses the y-axis. It's also a good way to think of it as the place where x equals 0. That will be your intercept, your y-intercept or b value. The other thing to remember is that a line is simply a representation on the coordinate plane of all the possible solutions for your equation. So given an equation like this, y equals 2x plus 1, I've drawn a picture here of a line that would describe that equation. What that means is for any value x that I put in here, I'm going to get a corresponding value of y. And that coordinate point will lie somewhere on my line. If I connect all the solutions together, I'll have a line. So remember to think of the equation as also all of the possible solutions to that equation. Now, when we talk about systems of equations, really what we're discussing or looking at is where two figures, in this case, two lines, intersect. Now, you can have system of equations with other shapes like parabolas, quadratics, circles even. But for today, we're going to focus on systems of equations involving linear equations or lines. Now, you can see here I have two different lines with different slopes and different intercepts. But as is the case with almost every line in the universe, it's going to intersect other lines at some point. Only parallel lines will never cross, and so they will never have a shared solution. But almost every other line, if you go far enough, will eventually intersect, and that's what we're trying to find out in a system of equations. Could be a number of reasons why you would do that. In longer word problems, it might be to decide between two different companies charging two different rates. But very simply, you're looking for the intersection point where the two lines cross. That will be a coordinate point represented with a value for x and a value for y. That's essentially what we're solving for in a system of equations. We're usually given two or more equations, and we have to find out what will be the one solution that will solve both of them at once. That will be the intersection point. Because if each line is representing all the solutions for that equation, then the place where they cross is the one solution that will solve both of them. Now, in going over to the algebraic side in the equations, part of the challenge is often on system of equations that you have an x and a y in both equations. So it's not a simple step of solving for one automatically or immediately. You have to take a preliminary step to somehow get rid of one of the variables and leave the other one so you can solve for it. I can only solve for one variable at a time. So I need to find a way to get rid of the other variables. The two methods that you will use most often on system of equations are elimination, where you essentially add or subtract elements of the equations to get rid of one of the variables, or substitution, where you find out what the value of one variable is in terms of the other, and then you can substitute that into the other equation to eliminate the variable. Some students are a little more biased towards one of these methods or really are more familiar or comfortable with one of them. That's fine. I've got some good news for you. Either one will usually work. So either method will get you to the answer. But the best students know how to do both of these because given the setup of the question or the equations, usually one of these is much preferable or more preferable. It's very much quicker, much easier. So you want to be skilled at both if you want to do well on systems of equations. You're going to get them in a variety of forms, as we'll see in a moment, and we want to make sure that we can solve them in a number of ways. Now, in this particular example, I could actually solve for the solution here. I have two equations. What's nice about the equations is they're already both in the mx plus b form, which means I know they're both equal to y. This whole thing, 3x plus 1, is equal to y. And this whole thing, 2x plus 3, is equal to y. If you're given a system of equations where both are set equal to the same entity or variable, you can set them equal to each other. That's a great rule to remember throughout the math section. When two things equal the same thing, they also equal each other, which means I can simply set these two equations equal to each other. Now I'm just going to solve for x. So I'm going to subtract 2x from both sides. End up with x plus 1 equals 3. Then I'm going to subtract 1 from both sides. And I end up with x equals 2. If that's all I needed to solve for, if I want an entire coordinate point, I would just have to plug that x back into either equation to find my y. I'm going to try it in the first equation. So y is going to equal 3 times the x I found, which is 2, plus 1. 3 times 2 is 5, plus 1 is 6. So this coordinate that solves both equations is the coordinate 2, 6. You can see how the equations connect with the lines. The algebra connects with the geometry. Let's take a look at a few examples. In this first question, we have if x plus y equals 17 and x minus y equals 7, then what is the value of x? One good first step on systems of equations is to line up your equations with the variables in corresponding places. So you can see how many x's, how many y's, and how many constants you have. Constant being obviously a number with no variable next to it. In this case, the 17 or the 7. Now, in the process of elimination, what my goal is to add or subtract equations from each other such that I will eliminate one of the variables. Always keep that in mind. Your goal is to get rid of one of the variables. Now, if I look at these two equations, if I want to solve for the value of x, if I want to leave x in my final equation, then I want to get rid of the y's. If you can observe the relationship between the two, there is a simple way to do this. I'm just going to add the two. If I add the second equation to the first one, well, x plus x gives me 2x. Y plus a negative y, well, they just cancel out. These are gone. That was my goal the whole time, accomplished. Next, I've got to add the 17 and the 7, and that's 24. Dividing both sides by 2 allows me to solve for x, which I find is 12. That's all the question asked for, and so I'm done. If it asked for the full coordinate of the solution, I would just plug the x back into either equation to find what the y is. Sometimes with elimination, you won't be able to simply eliminate one of the variables by adding or subtracting immediately. What you're going to have to do is a little multiplication. Let me show you what I mean. If 2x plus y equals 24, and x minus 3y equals 5, then what is the value of y? Again, pay attention to the question. I need the value of y in this one. So my smart move here would be to somehow get rid of the x's. Now, if I look at my equations, I always want to line up the same variables so I can see and compare in the equations the amount of x's and y's, because ultimately I would love to match up the same amount of x's or y's and then either subtract them away or add them away, depending on the signs. It's really up to you. Just be careful. In this case, if I found a way to double the second equation, I'll have 2 x's in both equations, and then I could subtract them away. So I'm going to do that. This second equation, I'm going to multiply everything, distribute a 2 to every term in the equation. Now, some of you may have learned to multiply by -2 and then add, or you can multiply by +2 and subtract. It's really up to you what you're most comfortable with. In this case, I'm going to multiply by -2, and that's going to change my second equation now. If I distribute that -2, I'm going to end up with -2x. -2 times -3y gives me a +6y. And -2 times 5 is -10. Now, I can add these equations. Okay. You can ignore the middle one for a moment because I already doubled that. So 2x plus a -2, 2x plus a -2x, those cancel out. That's exactly what I was going for. So that's 0. We have 1y plus 6y's, 7y's, and 24 added to -10 really is just 24 minus 10, which is 14. Divide both sides by 7, and you'll quickly see that the value of y is 2. So from a somewhat complicated looking first setup, I was able to find a simple answer of 2 for y. And that's all the question asked for. Just a reminder, what I did here was in order to eliminate the x's, I doubled the second equation. So with elimination, you may have to look at the equations and say, hey, maybe if I multiply by a simple number like 2 or 3 or 4, I can match up the same number of x's or y's and then eliminate them away with either addition or subtraction, depending on the sign. I do want to point out one more thing to look for on elimination problems. And that's a reminder to focus on the question itself. They will often be asking you for what the value of x or y is, or both. But once in a while, they're going to ask you for something different. In this question, given the following system of equations, what's the value of 9x minus 4y? So this is ultimately the value we want to find. Of course, in my system, I could solve, just as I've been doing with elimination or substitution, I could solve for x or solve for y, and then go back in and figure out what this expression 9x minus 4y equals. But let me give you a hint. Pay close